Hello again. We have ourselves one more word problem. This one is about Katie and Charlie leaving school. They both leave at the same time, and Katie walks home 3.5 miles. Charlie walks to water polo, which is 2.5 miles away. Katie and Charlie arrive at their destinations at the same time, which means that the time that they take is the same. So t is equal to each other. Katie walked 2 miles per hour faster than Charlie. Okay, so the question is this. What were their speeds and how long did they take? Okay, so let's do a little drawing. So Katie had to walk 3.7 miles. And then that took her a certain time. Charlie had to walk 2.5 miles. And it also took him some time. And their times are equal. All right, let's see. How would we write this out? Well, let's think about this. We're trying to figure out what their speed is. And speed, the speed that we're using is miles per hour. So miles per hour. Okay, so maybe we can write Katie in some miles per hour. And then Charlie in some same miles per hour. So we don't really know how many hours, but we do know t. So we can say that. That can stand for some amount of hours. So for Katie, we can say 3.7 over t. And then for Charlie, 2.5 over t. All right, so that's their speed. Cool. All right, let's uncover what I have here. Dun, dun, dun. All right, cool. So this is a neater way of saying it. So Katie travels 3.7 miles. Charlie travels 2.5 miles. Same as down here, right? Okay. Their speed, we know that Katie walked 2 miles per hour faster than Charlie. So her speed is going to be x plus 2. And then Charlie's speed is going to be x. And that's going to stand for miles per hour. And then we're going to write their speeds in terms of miles per hour, just like we did down here. So Katie's is 3.7 over time. And then Charlie is going to be 2.5 over time. Okay, I'm going to erase this because I think we're going to need that space. So we know that the time that they both spent is the same, but their speeds are different because Katie went faster. So we can't set this equal to this. Let's see. Okay, so here, time for, let's say, Katie's time is equal to Charlie's time. Okay, what I'm looking at is this. We have speed over time and this speed, right? I wrote Charlie's speed is x, and then Katie's speed is x plus 2. But then we also have another representation for speed. So technically, this speed should be equal to this speed, and this speed should be equal to this speed. So let's say x is equal to this, and that is equal to this. All right. So let's say x plus 2 is equal to 30 and 3.7 over time. And then for Charlie, we have x is equal to 2.5 over time. Now, this gets a little bit confusing because we have two variables now. We have some speed and we have some time. But this is what we can do. We have x over here and t over here, and we have x and t here. What we're going to do is, in order to get rid of this t, we're going to write t in terms of x. So here, let's multiply both sides by t. So we're going to get xt is equal to 2.5, and then we're going to get t is equal to 2.5 over x. Great. So now we know what t is equal to in terms of x. So let's put that back into here, or here, and then get rid of t. Okay. Let's see. I think I'm gonna rewrite this equation. I'm gonna multiply this side by t and this side by t. So I'm gonna do t over here. Okay, multiply this side by t, gets rid of that. Multiply this side by t, I get t x plus 2 is equal to 3.7. Okay, now I'm gonna substitute that t, this. So I'm gonna rewrite it. I'm gonna say 2.5 over x times x plus 2 is equal to 3.7. All right. Let's multiply that out. Okay, so we're going to have 2.5x over x. Oh, cool. So those cancel out. Plus 2.5 times 2 is 5 over x is equal to 3.7. Okay, I think the best thing to do is maybe not cancel this out just yet, but let's multiply everything by x. So let's do this times x, and then this. That's an x. Okay, so if we multiply, okay, now let's cancel it. So cancel these x's. X and that gives me 2.5x. X over here cancels, and I'm left with just 5. And then here gives me 3.7x. Okay, I have more x on this side, so let's take it out from here. So minus 2.5x minus 2.5x. And then that's going to give me 5 is equal to 1.2x. Or x is equal to 5 over 1.2. What is that? That is, it's like 4, right? Because like 50 divided by 12 gives me 48. And then 2, it's like 1, so 4.1. So 12, 8. 12 can't go into that. 80. It's like 7. No, less. 6. Okay, 6. About 4.16. And that's x. So that means that Charlie walked 4.16 miles per hour. And then Katie went 6.16 miles per hour. Cool. Oh, okay. And then one more thing. How long did it take? All right, let's delete some of this stuff. And delete that. Let's delete a little bit more. Okay. So let's see. Time. Oh, good. Here we have time is equal to this. So time is equal to 2.5 divided by 4.16. All right, that's a lot. So I'm going to use a calculator. Handy phone. What is this? 2.5 divided by 4.16. Okay, I got 0.6009. So I'm just going to call it 0.6. And that t is in terms of hours because it's miles per hour. So that's hours down here. So it's going to be 0.6 hours. Okay, 0.6 hours. No one says that. So let's change that into minutes. So 0.6 times 60 minutes per hour gives me 36 minutes. Okay, cool. So their speeds were 6.16 and 4.16 miles per hour. How long did it take? It took them both 36 minutes to walk. Cool. All right, that's it. Let me know if this made sense, and if there are any other word problems that you'd like me to do, feel free to add them in the comments below, and I will do my best to solve them. All right. I hope you had a great day, and yeah, keep enjoying life. It's okay if these word problems don't make sense. There's no real like formula for these. You just kind of get more and more practice, and it helps you to identify like how to put them into certain forms. So sometimes the best thing to do is just look at the answers and see what they did and just understand why they did that. All right, cool. Take care.